This is Lesson 1-1, Introduction to Functions for Algebra 1. You can see our goals there today. We're just really going to talk about some vocabulary, and I don't think you'll find these questions drastically difficult. You should be able to breeze right through this. I don't want to set you up for failure, but I think you'll be in good shape. So the goals here will be I'll be able to identify relations, functions, domain, and range. So just some vocabulary on those. I'll be able to identify when a relation is a function, and I will be able to find corresponding values for inputs and outputs of relations and functions. So what you need to know about relations is it's just a set of ordered numbers or ordered pairs. Okay, so ordered pairs. Okay. So it doesn't have, it's very loose, but you do have to have two numbers that go together to be a relation. It's kind of like you can't have a relationship with somebody if you're just by yourself. It requires another person. So sets of ordered pairs are just a set of numbers. Like this could be one of the items in the relation, 3, 4. And so 3 corresponds to 4. Now a function is also a relation, but it's a set of inputs to a set of possible outputs where each input is related to exactly one output. So what that means is it's kind of like when you go up to a soda machine. A soda machine is a relation that is also a function. When you press Sprite on the soda machine, you're going to expect a Sprite. But if you press Sprite and you get a Coke, you would say that machine is not functioning. It's not a function because the Sprite button didn't give you the same output that it gave you the first time. So that means each input, so each Sprite button is related to exactly one Sprite being pushed out the opening, okay? So what's domain? Well, the domain is just all the inputs that we can plug into an equation and get back a real number for outputs. Okay, so domain just is all the inputs, and range is all the outputs that you can ever get out of an equation or a function. A picture, it could be a graph, it could be a table. So there are lots of ways you can represent a function. So let's look at some of those. So this first example, you can see that this is a list. This is just a list of ordered pairs. Okay. Or another way to say it is these are points. They're XY pairs like that. Okay. Well, the domain's just all the X coordinates, so all the first values. So -2, and these are in a set. So I'm going to draw a little set bracket there. -1, 0, and 1. Those are all the X values or inputs. And then the range, that's the R. So capital D is domain, capital R is range, is just all the outputs or all the Y values. So again, we have this set bracket, and then we got a -1 and a -3 and a -5. And a -7. Well, those just look like they're a bunch of odd numbers. So look at B. B is a table. So they're still ordered pairs. You know, they could have been in parentheses like this, but they chose to put them in table form. And once again, domain's just all the X values. So I'm going to put a set bracket and go -5, -7. Whoops. My 5 doesn't look very good. -7, -9, -11. -13, squeeze that in there. And then the range would be all the outputs or Y values. So that'd be the -1, -2. Well, these just go down by -1 each time. And there are the range values. Well, C is called a mapping. And a mapping just has one bubble that is domains and one bubble that is range, or this is inputs and this is output. Whoop. And output. Okay. And so the domain's just looks like a 6 and a 7. And then the range is the 2 and the 3. On the last one, it's a graph, and this is called a discrete graph, because discrete means you can count the inputs and outputs. So you can see there are clearly dots on the graph here. There's 1, 2, 3, 4. There are 5 dots. So we can count that there are 5 points or 5 sets of ordered pairs. So let's go across the graph here and just name all the x values. So there's one there, right there, and there's an x there and there. And so these points represent an x and a y value. So all the x values in are -2, -1. And then it skips over to +1, and then there's one at 2, and there's another one at 3, 4. And then all the range values would be like here, and then here, and that one duplicates. There's 2 dots with the same y value there. So all the ranges would be 3, and then 0, and then -2 and -4. So like if you were to write the coordinates of this point is -2 on the x, and it's at +3 on the y, and so that would be the ordered pair. So -2 would be the domain, and 3 would be the range. And you simply do that with every point there. This point here, it's got a x of -1 and a y of -2. So my third pairing then is let me check that here. -2, -3. So this is, -1 goes with, that's 0. It doesn't go with -2. Well, -1, -2. Let me check this again. Let's start all over. Let's name more points here. So this first one is -2, 3. This is -1, -2. This point is +1, -2. This point is +2, -4. And this point is 4, 0. So now let's go -2, -1, 1, 2, and 4. There we go. And then the range values are 3, 0, -2, and then -4. Now notice there's one less range value because right here, this pair of points, the range value duplicates. And I think that's what I did. I didn't count the right ordered pair there. I think we're okay. So, all right, here's the bonus. The domain is just all the first shapes. So we could say the heart, and then the square, and then the triangle. And then the range values are the smiley face. Oops, that's not very smiley. There. And then we've got a heart. And we got another smiley. We don't need to write the smiley twice. We've already written it once, so we don't need to repeat that. So you don't need to repeat your range values or if your range values repeat, you don't need to copy them down twice. Okay? How do you know if a relation is a function? Well, a function is a mathematical machine, and you input a value that is manipulated by mathematics or an equation, right? So to make a given output, the key is each input must be paired with exactly one output. You figure if you take some mathematics and you input an x value of 5, For example, let's say you input an x value 5 into the machine and it spits out a 10. Well, the mathematics there might have been 2 times x. Maybe that's what it was. Okay, like this would be our x, and we'd get a 2x out. Or maybe the math there is x and then x plus 5. So in both cases, 5 times 2 is 10, and 5 plus 5 is 10. So it doesn't matter what the math is right now. We'll talk about that later. But that when I plug 5 into that mathematics, it's always going to give me 10. I'm not going to get a different number the second time I try that math, because math has rules, right? So when you buy a drink from a soda machine, you press a button and a can of soda is dispensed. That's the output. When we talked about this one before, you choose Coke and get Coke. But what if you press buy another and press Coke and you get a Sprite? Again, that machine is broken. It's not functioning. So the same input should always produce the same output because of the mathematics. So decide if relation's a function or not. So what you're looking for are where you have a domain value that appears twice in the list, and you're looking to see if it's paired with the same range value. Well, this 5, that's the input. These 2 inputs should give you the exact same output, but they don't. Those are not the same. So this is not a function, okay? So look at B. Do you see any domain values that repeat? No, I don't either. So this is a function. Okay? How about the next one? Well, I see a 7 and another 7. But what's nice is they're paired with the same output values. So this is a function. X, all different, it's a function. In a mapping, the inputs and outputs, the inputs are all the same. That is a function. In this graph, we've got an x value of -4, a -1, a +1, and then we have 2 of them with an x value of 1, 2, 3, 4, but the outputs are a 2 and a -1. And those are not the same. So this is not a function. Well, here on this line, do any x values repeat? No, this is a function. We'll talk a little bit more about graphs. So on a graph, then, something that's not a function would look like this. Because now you have, like, for example, let's say that's our x value. We have 3 different points that correspond to that x coordinate of, say, -1. Well, you got a positive y value up here, another y value over here, and you got another y value down here. 3 different places where it crosses the y-axis, and they are all different. Okay? So we give functions letter names like f, g, or h. In a lot of cases, we just want to refer to a function, and we can't just say, like, you've seen y equals 3x or something like that. We don't want to constantly refer to all of the functions as y. So we give them different names so that it's easier for us to talk about them. Okay, so f of x is a set of ordered pairs, g of x is a table, and h of x is a mapping, right? So these are ordered pairs. This is a table, and this is a mapping. Okay? So what function notation means is written as f of x, or f with x in parentheses, means the output value of f that corresponds to the given input value of x. So x being in the parentheses is saying we're taking a value of x and we're plugging it in place of x, or we're looking for x in our table or ordered pairs, and then we're going to find its corresponding f value, or what is f of x. So we're looking for the f that corresponds to our value of x that we chose, okay? So how would you do f of 2? Well, what that's saying is with 2 being the input, what is its partner value or output? Well, here's the 2 in the inputs or the domain, and you notice it doesn't appear anywhere else, and then its output is 3. So g of x says, what's g of negative 3? Well, I'm looking at this table now, and I'm finding the input of negative 3, and it doesn't have any other negative 3 in the inputs, and its partner y value is 2. H of 5. Well, 5 is the input value, and I'm looking for the output value that corresponds to it on this mapping. Well, it's the 0. J of 3. J is this graph of points up here. Again, it's discrete. I can count them. There's 1, 2, 3, 4, 5 points. And I'm looking for where x is 3. So here's x is 3. And this is the point that corresponds to it. And so I'm just looking for its y value, which is going to be 1. Okay, now you try number 5. What's g of 0? Oh, excuse me. This is now saying the output is 0. What's the input? So what x value gives me an output of 0? Well, here's 0, and it came from an input of 5. J of x, an output of 2, came from an input of negative 1. F of x is 3. So I see that an output of 3 appears twice, here and here. And so the inputs are either 2 or 1. And then h of x, h of 2. What makes h of x 2? Excuse me, what makes h of x 2? Well, here's 2, and it came from a negative 3. Okay? So are all of these functions? Let's look at them and see if any of these are not functions real fast. Well, there's a repeating x value here. I got a 1 and a 1. So this is a big no. Not a function. I don't see any repeating x values in G, so this one is a function. 3, negative 1, 1, 4, 5, this is a function. And if you look, the x coordinates of these points are negative 4, negative 1, 0, 2, and 3. So this is a function. Okay. Did we do j of 3? And j of 3 was 1. There we go. Okay. So graphical functions. Here's a graph of function g. The equation is not given to us, but we can use the function notation to represent the outputs of various inputs. So what is g of 0? Well, that means for an x value of 0, what's the corresponding y value? Well, it would be 3. For g of 4, I'm going to slide along here to 4, and I'm going to move up the graph until I get to this point right here, which is 6. For g of 6, I'm going to move to 6 on the x-axis. I'm going to move up the graph to this point right here, which has a y value of 1. Now it says find the x for which g of x is 3. So now I'm going to look here at 3. Erase that one. So I'm looking for an output of 3. And I see several values. In fact, there's an infinite number of values here, because there are points between 0 and 2 that work. So all the points between 0 and 2 work. Then there's a point right here on the graph, somewhere between 4 and 5. There's another point on the graph over here at 9. So there's lots of values here. There's anything between So I can say from 0 to 2, and then there's one at like 4.8, somewhere between 4 and 5, and then there's one at 9. So we'll talk more about how you can represent this from 0 to 2 at another time. At this point, I just want you to realize there are a bunch of points between 0 and 2 there. Notice like there's, 0.1, 0.2, 0.3, 0.4, 0.5, right? So we'll talk about how to represent those another time. How about where is f of x equal to 6? Well, that's a little easier. Here's 6. So that's this point right here. And the input for that was a 4. And if f of x is 0, so we're looking down here at 0 for the y value. So at 0, I'm looking for this value right here, which is 7. Okay, so that's using a function, a graph to evaluate a function. All right, when does a graph represent a function? Well, the vertical line test is what it's called. That can help us determine if a graph represents a function or not. So remember, a function has exactly one output for each input. So look at this first graph. If you notice on the red curve, it doesn't matter where I draw a dotted line, it's only going to hit the curve at one point. So let's say these counted by ones, for example. 1, 2, 3, and 4. You notice that 1, the x value of 1, only has one point that corresponds to it. And so does 2, just has 1 point, 3 has just 1 point, and 4 has 1 point. But what happens if I squiggle the line back and forth, and then I draw, let's say this point is 2. Well, 2 has 3 different points, each with their own unique y value. Maybe they're 1, 2, and 3. Well, that's not a function. 2 can't give you 1, and then you do some math to 2 again, and you get 2, and then you do math again to 2, and it gives you 3. Well, I don't know any math that does that. Okay? So I can't think of any math that takes a 2 and gives you a 1, and then when you do it again, it gives you a 2, and when you do it again, it gives you 3. It gives you 3 different outputs. That is not a function. So if you just look at whether a vertical line hits the graph at more than one point, okay, if the vertical line intersects the graph at more than one point, it is not a function. Okay, so look at this first one here. Which ones are functions then? Well, here's a vertical line that I can draw in here. And it hits 2 points at the same time, so guess what? That's a big no. But the second graph, I can't put a line through there that hits the graph at more than 1 point at a time, so this one's going to be a yes. Well, this one's clearly a no. I can just draw a line right through here, or I could put one over here, and both of those hit the graph at more than 1 point, so this is a no. Quite obviously, this flower is a no as well, right? How about this next graph? The graph goes it doesn't go vertically here. It's still going to the right as it's going up. It's just going up much faster. So a vertical line is only going to hit it at 1 point. So this is a yes. And see what you think about that last one. I think it's also a function, okay? So we were half and half there on those. So you're going to find an assignment there, and you just need to understand that it says it looks like a long assignment, but several of those go very quickly. They don't take very long to identify what they want, okay? So I gave you a goal of a SMART score of 70 on each one of those. These are all in iExcel, and they all have a star by them.